Thank you all for coming. This is a beautiful venue. Thank you for the opportunity to tell you about this project. This opening slide shows you an example of one of the workflows that I was dealing with when I inherited this project. But first I'll tell you a little bit about, if I can advance my slides, which is not working. We were doing so well. Maybe we'll just do it this way, just for simplicity. All right, so I'll tell you a little bit about myself. I'm a recovering scientist. My PhD is actually in biochemistry and cell biology. I taught myself Python a few years ago and had a pretty miserable time actually transitioning into getting full-time work. I'm happy to talk about that with anybody who wants help making that transition. And my blanket disclaimer for this talk is that I'm doing DevOps in my current role because I have to, not because I love it. But I do find it satisfying. There's a lot to be said for being able to support your own needs. And I'm working at Oath, which most people have not heard of, and pretty much everyone who asks me the name asks me to repeat it again, because when they hear me say it, they think it's a different word. So I was originally hired into Yahoo a year ago, and I joined the Bright Role team. And the team I joined is called the Product Hackers. And this was a role that Bright Role invented. It's kind of an interesting mix of data engineering and data science in a very applied sense. So our role is to support the product. And in this case, the product is advertising, which means it's a lot of data and there are a lot of moving parts. But our charter really is to be involved from the beginning to the end. So we help build data in from the design of a new feature through testing and monitoring it. And if anything breaks, our team is the one that gets called to dig into the data that would be sort of log level, event level stuff that would be more than the analysts could handle. And it's more than you can handle with just SQL, basically. So things that would have to go into a very large database, which means that we have our own databases. So with that, I'll ask, how many of you are currently using Airflow or have used Airflow? Is there anybody here? One person in the back, okay. So if you're thinking about this, these are the questions you might want to consider. How many of you are using cron jobs right now? Okay, a lot of people. So you can use cron jobs with Airflow. They don't have to be ETL, but that's our primary use case. And I'll talk more about what I mean by that and what a typical job looks like for us. How many of you have to rerun cron jobs regularly when they fail? You have to go in manually and restart it because something broke. Okay, how many of you have had that happen ever? Pretty much everybody, okay. So, and how many of you were on call? Like for if a cron job breaks, somebody calls you and says, hey, this thing didn't, this one's nodding, okay. So Airflow, for those of you who aren't familiar with it, it is an open source Python library. The idea is that it builds Python objects to represent directed acyclic graphs of tasks. So each task is executed by an operator, which is also a Python object. And the operators are using hooks to connect to external resources. In our case, most of those are AWS services. Some of them are internal databases. And you can have a lot of these. So we have something like 50 different connections to our Airflow. And then the nice thing about it is that unlike a cron job, you can have different states for all of your tasks. And you can restart them because it's able to cache the results and track if something failed and it doesn't need to be rerun again, or if it failed and it does need to be rerun again. So you don't have to rerun the whole job every time. So when I inherited this project, there was a lot of red on our dashboard. We had 95 different jobs that were running, but most of them were really similar. Most of them were doing things like looking in S3 for logs, running some kind of parsing, which might be Pig or Spark or some other elastic MapReduce type of step. Often joining tables, creating tables, dropping tables, that sort of thing from our Redshift instance, which our team has its own Redshift cluster in support of our data activities. So it's separate from the production data systems, but we do need that data to be there. And there were a few times where something had failed and we needed to go in and figure out some way to hack it back into place. And I was on call for the first time in my career, and I wasn't happy because I had to keep restarting things that were red, right? And I felt like, what's the point of having this totally automated system that's running in Python and then having to do everything through a GUI? But also because there was still this other problem we had where Redshift was filling up with too much data. And we had this habit of saying, well, you know, every few days we'll go in and drop tables by hand, which was silly. So our Airflow setup is actually pretty straightforward. We really only have two instances. One runs the scheduler and the web server, which gives you the nice GUI. And then we have a separate instance which acts as the worker, and I'll talk about why that's like that. And then there's a messaging system, and there's a database that keeps track of the tasks for you. And as I mentioned, most of our jobs are doing this loading into Redshift kind of stuff. So I didn't really know how Airflow was working, so I wanted to understand a little bit about what all these steps were doing. And most cloud scheduling systems have a similar structure. So what the scheduler is doing is actually monitoring all the tasks and all the DAGs. And it has triggers based on your dependencies. So you can tell it, I want this to run at a regular time. I want it to look upstream to see whether other tasks have finished or other DAGs. So there's a heartbeat that runs every minute or so, and it checks to see, are the previous tasks done? And that's all handled by a messaging protocol, which is a pretty standard messaging protocol. And we're using Celery, which I had used in a previous job for web things, but I hadn't really needed to think about the fact that it was messaging or why that would matter. And I'll explain a little bit about, at the end, why understanding a little bit about Celery is useful. And then, you can add additional layers of control on top of this. So you can have pools that will let you take better advantage of not overwhelming your resources. So Redshift, for example, it's not great with concurrency, and it doesn't know how to manage that itself. So I found it really helpful to tell it, let's only have 2 loads at a time, maximum. Otherwise, everything comes to a screeching halt. But you can have a pool of 5 or more dropping steps, and the database is fine. It's not going to have any problems doing those at the same time. But it has some weirdnesses. So if you dig into the source code and if you have any kinds of problems, you will find that it reads like Python written by people who mostly know Java. And those of you who are laughing know exactly what I'm talking about. The DAG files themselves are a little strange looking, and I'll show you a couple examples of those. And you can't generate DAGs within other methods unless they get spit back out to the top level. So that makes some things impossible to do, basically. The other thing is if you want to go in and grab things from specific tasks, like for your tests or for troubleshooting, you can't use the task IDs or attributes like the name of the task. Instead, you have to iterate through and get the index and do it that way. So they have lovely object attributes that look very Pythonic, but then you can't use them for lookups. So here's an example of a DAG. We're importing an operator that would connect to Postgres, which is the one we use for Redshift. We're importing an operator that connects to MySQL, and some things that handle security. So one nice thing about this is you can abstract away all of your access keys. So you can commit all this code into GitHub, and you don't have to worry that your AWS secret keys are out there for everybody to see. And then we have just, 3 steps, really. It's dropping the old table, creating a new one, and importing data into that table. And then you tell it how to connect those steps together. So it kind of looks like a lot of code, but mostly it's just arguments telling it settings like, don't retry this 50 times. Just retry it 3 times, and if it fails, then let me know. But the nice thing about this is that it's all, and by the way, it's in Python 3. And you can get it all green pretty easily, and it just runs, and it's completely hands-off. I haven't had to do anything to this DAG since I wrote it. It was a major upgrade from our previous, and we have quite a few like this. Some of them have a lot more steps than others. I'll tell you an example of something I wanted to do to simplify, again, a thing we were doing by hand. I mentioned we were dropping tables manually. And I was like, I feel like there should be a way to automate this, right? But in order to do it, I needed to be able to dynamically generate tasks because the names of the tables are updated with the date. So the name of the table in Redshift is actually changing every day. And we needed a way to work around that. So in the old version of Airflow, I had to do it by creating a new DAG every day. And I was able to automate that, but then you have to actually manually switch it on in the GUI. In the new version of Airflow, you can actually do a sub-DAG, which makes your life even simpler. So you can say, okay, create a task and add it into the list of DAGs, and then you have to iterate through the list of tables, in this case, that you want to create tasks for, and it makes a new DAG every day with each of those new table names. And then you have to go into the GUI and turn it on. In the new version, thankfully, now it's got the ability to generate sub-DAGs. So what this is doing is keeping the same DAG, and it's generating a new step automatically. And we added in a bunch of helpers to help us add in the dates and dynamically generate those and set our limits. Can anybody look at this and guess what the one thing was that we had trouble figuring out when we wrote this sub-DAG? Because we had a bug in it for a little while, and it was not immediately obvious. Got one person back there with a great look on your face. The braces, exactly. So this Jinja stuff, 4 brackets. You had to have 4, I don't know why. It's the magic number. But again, like I said, there's some things in here that it's kind of un-Pythonic in the sense that you're relying on things like Jinja for these sorts of macros. So that was a little bit of a drag. But ultimately what I wanted to do is make this a little more productionized, which meant collaborating with our ops team and taking advantage of having them help support this cluster for us. But what that meant was I needed to revamp our development environment, which had previously been in Vagrant. So I rebuilt that in Docker with Ansible. And then I went and talked to ops. And they said, okay, so we do everything in Puppet. And I was like, oh dear. And I talked to the guy who was helping with Jenkins, and so we started setting that all up because I wanted automated testing, and we didn't have any tests when I inherited this repo. So I had to figure out how to hook all those things up, and then I had to convince my teammates that it was time to write some tests. So Puppet was being used to manage things like, again, access keys, but mostly for provisioning instances. So that meant that we had to tell them all about Python dependencies because our ops team had only done Ruby in the past and C. They were totally unfamiliar with virtual environments, and our Airflow instance had to live on a shared box with another team's Airflow instance, and they were running a different version of Airflow in Python 2 without a virtual environment. So that was kind of fun to figure out. And ultimately, in Jenkins, we were able to, write in the little Groovy script that Jenkins calls, make me a virtual environment, pip install all the stuff I need, create the Docker file, all that good stuff. One of the other tricky things that we ran into was that because of this shared instance stuff and the Puppet stuff, I had to write a script to tell Airflow where to find its home directory, which is another kind of un-Pythonic thing about the Airflow project. You'd think that they would give you this as part of the project, but it didn't really have a self-contained way to do this. So I had to tell it, okay, really we need a few different versions of this, right? We need one for running locally, we need one for running on Jenkins, and we need one for running in the production environment, which means it has to be able to find the path and the Python path and all that good stuff, no matter where it's living. And worse than that, Puppet kept trying to overwrite the Airflow configuration file. So we had to basically let it do that and then overwrite it again with the version that we actually wanted. And then I was using Docker a little bit. How many of you are using Docker? Okay, quite a few people. So I probably don't need to explain what that is, but it did make it nice for local testing, and so that I could say to my new teammate, okay, here, just spin this up and you're good to go. And it was actually pretty easy to set up. And personally, I'm a huge evangelist for testing, so I'm just going to take a moment to make a little speech about why testing is good. Personally, I find that I code a lot faster when I write tests. And it makes me feel a lot safer, which means that I'm more willing to move fast and break things if I need to, but also I feel a lot safer knowing that if I'm going to push something out to a production environment, it's probably going to be really stable. So I strongly recommend writing tests. And I needed to come up with a way to, use the tests. Oh, is it active again? Haha, thank you. Good eye. Or maybe not. Okay, we'll just stick with this. And I'll share the slides out for anybody who's interested. I needed to come up with a way to write the tests so that they could be reused, because most of our tests needed to do the same thing over and over again. And I wanted to use them as a way to sort of enforce best practices. So anytime you were using a Postgres operator, I wanted the job to be idempotent, so you would always drop the table and create the table, and never create the table but not drop the table, and all that sort of thing. So I came up with a way to instantiate the unit test so that it could be run on the DAG file, because again, the DAG object and all that stuff is top level in these files. So it's a little weird. It's not really how you would normally do unit testing in Python with classes or other kinds of methods. So instead, I just treated the DAG file as an object and then went in and grabbed each task as an attribute on that object. And that works okay. And the nice thing about this is I can give it to, say, the newest guy on my team who was pretty new to Python and had never done any testing before. And he was able to follow my instructions and get some stuff working and get some confidence about running tests and writing Python and having a DAG that actually worked, that he did himself. So all he had to do was instantiate these tests and tell it, okay, we're setting up this particular DAG. These are the types of tasks that we're testing. And you can parameterize this however you want. You could say, oh, for this one, we want to have it retry this many times or whatever. But basically, this made it pretty painless, and I'm fairly confident I can even get my last team member, who's the most stubborn, to give up her cron jobs and to start writing tests and actually write an Airflow DAG. My last piece of advice for anyone who's thinking about doing this is the one thing that's still a little bit dangerous about Airflow, which is backfilling. So the good news is you can backfill now from very specific time windows if you want to, and we've done that successfully. The bad news is if you forget to deal with the start date of your DAG correctly, it will try to backfill to like the beginning of time. And, and what happens is Celery gets completely overloaded and freaks out. And then what you see is that the heartbeat goes away. All your DAGs will show up as running. They're not red, they're green. It thinks they're running. And so actually what they are is zombie jobs, and you end up having to mark them all as if they succeeded in order to get it to stop doing that. So I recommend not getting yourself in that situation because it's a little bit scary when it happens. And with that, I'm going to tell you I had some help from previous hackers on my team. The ops people were awesome. And as I mentioned, my newest team member is already contributing to this project. And I'll take questions if anybody has any. Thank you. Why? Oh, again, for the reason that we were running out of space on Redshift. So just to create better habits about, for some of these tables, they need to be replaced in place. They have the same name every time, but they need to get updated. And in other cases, we need to make sure that we're not just accumulating a ton of tables. So it depends on the use case. There's some where the table name is going to always have a date in it, and some of them it's not. So, but it's something to consider depending on what your Redshift or your whatever database you're using looks like. You don't have to keep your DAG synchronized because Airflow does it for you. So it handles giving them out to the workers if you have multiple workers that need to be running multiple DAGs. You can have more than one queue. So for example, we were sharing our Airflow for a little while with another team. So we had a set of DAGs and they had a set of DAGs, and you can tell it to schedule those separately, or you can tell it to mix them. It depends on what your use case is. But it handles all the pools, it handles all the queues, and we haven't had any problems with that, but maybe because we're not pushing it to like, you know, a 25 instance cluster. The source code, it's all in GitHub. Yeah, so this is a pretty typical setup, I think, because we use something similar at my last company. Jenkins is actually the thing that deploys the final version of the code. So after your tests pass, Jenkins pushes it out. Yeah, and that's also part of what Puppet is doing, right? Puppet is picking that up and making sure that the package gets deployed. Mm-hmm.
So how do you gather up the results of your tests? Are they like being fed somehow into Jenkins and displayed on a, you know, like on a dashboard somewhere, or?
Yeah, Jenkins does all of that for you. So if things go well, you get a little sunshine on Jenkins. If things go poorly, you get a storm cloud with a lightning bolt. It's very obvious. And you can click through and look at the logs and the standard out and all that great stuff. So if it's not clear what's happening, there's always a console. One more question back
here. Thank you. When I think of a graph, I think of NetworkX or Neo4j, and I'm just curious, is it conceptual here? So it tells it how to flow through?
It does in the sense that when you tell it set a task upstream, you can tell it this task depends on the previous one or not. And yes, and you can have branching, but they should be acyclic, right, by definition. Right. But yeah, you can absolutely have branching. You can have something where like it writes something out in a task, but you don't care whether that finishes before the other branch starts. Yeah, there's all that stuff.
I'd love to see a talk on how you made a transition to this field.
Yeah, that's a long story.
Maybe we'll schedule you for next year. One night.
Great.
Okay. Well, thanks a lot.
Next.
Okay. Can you hear me okay? Excellent. Oy. Hey, good. So I'm Steven, and real quick, so I was told that if I get nervous, I told a story by my cousin Dan about the time when he was working with a bunch of very famous bands. And one time he had to go on stage in Houston in front of 50,000 people and introduce Alice Cooper, okay? So before he went on stage, he turned back to the people behind the curtain and was like, how am I gonna do this? I'm supposed to in front of all these people and introduce you. And Alice Cooper turned towards him and said, when you go out there on stage, the lights, the stage lights will flood your eyes, vision will get a little blurry, and everything looks like a big bowl of oatmeal. So just speak to the big bowl of oatmeal. From Alice Cooper. Yeah. Okay, so what I'm actually talking about is not oatmeal or Alice Cooper. It's subject practical packaging for machine learning solutions. Okay. Wow, this is odd. I guess it was whenever I connected to the. Yeah, there we go. Okay. So, what, in case we don't already know, like, what exactly is Python packaging about, and why should we care about it if we were doing machine learning, right? So Python's deployment and packaging tools, they're very general purpose, and this is useful for us because they're not specific to any specific machine learning framework. They're not specific to scikit-learn, TensorFlow, whatever. You can use them on anything. As long as it's Python, you can use it. Even if it's not Python, you can still use it, but you probably use it on other things. It's not dependent upon any proprietary service. You know, it's also the case that it can help if you're making use of like Docker, if you're deploying out to servers on AWS or whatever, if you're deploying to a Hadoop cluster, or more likely Spark nowadays. This can be helpful. Again, because it's general purpose, it's very well tested across, you know, the whole wide range of projects that are hosted on PyPI, is going to be very consistent, dependable, and it's a very extensible solution. So it makes sharing and deploying easier. Whether you are just sharing with your friends, you're sharing with a client, you're working with engineers at your company, or wanting to share with the entire world. So the outcome that we hope for is to leave with a basic understanding of Python packaging and how we can use this knowledge to improve our workflow for distributing our machine learning solutions, right? So a few things I'm going to assume is that everyone here knows Python. We've used pip, maybe conda, or at least some kind of package manager. Also, it's very helpful if you have some understanding of the problems facing deploying machine learning solutions. Not absolutely necessary, but it helps give context. It's also the case, let's go and get a definition for what a machine learning solution is. For the context of this, for the purposes of this talk, a machine learning solution is basically something where we are providing a fitted model. And so this may include code for fitting the model itself, and just the API for interacting with that specific model. Nothing else. We're not deploying web applications. We're not doing any of that. You can use this, you can package it up, and then make use of this package within a web application, but that's not what we're doing here. Okay, so this isn't really a topic that you typically hear about in the data science community. It's not that people aren't using this stuff. It's just, it's not a sexy topic. It's not TensorFlow. So you don't see a lot of blog posts, a lot of talks about this, but people are using it and it's very useful. So let's see. So a few things to note. Again, because it's not something heavily talked about, so there aren't a lot of best practices already defined. So for this, I have drawn on just general software best practices, and then also industry experience that I've had. So real quick, we'll go over some basics. So here we're going to cover just enough basics, so the rest of the talk will make sense. So real quick, what is a distribution package? A distribution package, or really let's cover first a package. So a package is basically a directory that contains some Python modules, and this can be recursive. So a directory can contain a directory full of Python modules, et cetera, and that's a Python package. A distribution package is where you actually take that and package it up for distribution, right? It is the case, as we all know. These terms are very loosely used. Distribution packages will often just be called packages. I will try to avoid ambiguity. Okay. So here's an example of a directory that shows the bare minimums of what you need. So you don't necessarily have to have a license, but definitely if you're making your package public, very good idea, because it can affect, if you don't have a license, people can't really use your code, or at least it's a bad idea to use your code. It's also the case that having a license of at least, like maybe MIT or something like that, can help protect you from liability if your code does something bad to their stuff. It's also the case that you should include a README. As we should probably all know, a README may include directions on how to install your package, various, basically very important information about your package. And then of course we're going to include what we discussed a moment ago. We're going to include the Python package, which include our modules. It'll also include a data directory, which is what we're really interested in, because the data directory will include our model file. Now a file that is absolutely necessary for creating a package is the setup.py file. This is absolutely necessary for creating a distribution package because the setup.py file includes a setup function. And the setup function is something that we import from the setup tools package. And the setup function that is going to include various metadata that instructs the various tools on how to create our distribution package, how to maybe represent it on PyPy, PyPI, and then also, if maybe someone's using pip, how to actually install the project. And so things that includes things like the name, the version, the packages that are included, the versions of Python that our package works with. That's important. You want to have written it for 3.6 and someone trying to install it with 2.2. That would be bad. And then also, again, something that's very interesting to us is including data files with our distribution package, because that's how we'll actually specify how we're going to include our model. It is important to note that if we want to upload this definitely to the Python packaging index or potentially other, maybe private package repositories, there are other arguments that we'll need to specify. A very simple type of distribution package that we could create that is it's a good idea if we only have Python code in our package is a source distribution. If we were to include like C extensions, so we had C code that we need to compile, we would probably want to look into using a wheel. This does not apply if you list NumPy as a dependency, because NumPy is already going to be packaged in a wheel. So real quick, what is a distribution package? Well, basically a distribution package is a source distribution package. It's a distribution package where nothing has been pre-built. It's just basically taking everything in your project directory, packing it up and shipping it out as is. So again, if you had any C files, it would not pre-build them. Any sort of metadata files that need to be constructed when the package is installed, it does not pre-build those. This is just a very nice, simple approach that is appropriate for pure Python packages. For more information on that, I've created a companion blog post to this talk, and here is the link for it. I'll give it again. And there's a specific section on creating source distributions. I'll give this link again. Okay. So real quick, notes on distributing it. So let's say, a really simple option would be just to, take your distribution package that you built and email it. Sometimes it pays not to overthink it. Let's say you're working with a client and there's not infrastructure in place to distribute the package. Maybe it's something proprietary and you don't want to have it on the public Python packaging index. You can just email it. It's okay. It doesn't scale, so you definitely want to move on to other options. As you get beyond, let's say, like 2 users. So another option would be the Python packaging index, of course, as we all know and love. This is a source where you can upload your Python packages to have them available to the rest of the world. There are also, depending on maybe who your client is or what company you work at, they may have a private instance of the Python packaging index or some kind of private package repository. So again, for a deep dive on all of that, I've constructed a detailed step-by-step how-to on actually creating Python packages. It's at that link there. Let's real quick talk about like maybe some schemes, some architectures that we can use to more intelligently create packages for our projects. So it is good to note that these schemes are just suggestions that you should just sort of loosely follow and adjust to your specific needs. Because of course, the world of machine learning is very varied. There are many different scenarios that you can find yourself in. And in order to take full advantage of these tools that I'm presenting to you, that you know, people have thankfully made, need some flexibility. But anyway, so the simplest approach is just a single package scheme. Everything is just put into one single package and shipped like that. That's it. You put all your code to fit the model, and the API code, the code to actually use the model, all in one package. That's it. Again, that's roughly what the directory would look like. Just a single project directory with a package and a setup.PY file. So again, it's nice that it's simple, but there's some pretty heavy downsides to it. So it's definitely the case that anytime we make updates to any part of our project, we have to completely ship everything all over again. Okay? And we cannot version things separately. So how can we solve this? So, well, a solution is to split up those three major components. So create a package specifically for creating a model, create a package specifically for the model, and create a package specifically for actually using the model. So the end API that any web application or whatever that's using our model will actually use. So again, that's the quick description of the package that contains the code for fitting the model. That'll also include code for maybe pre-processing the data. So like if you have some text data, the code that you'll use to actually maybe tokenize some text or something like that. Then actually also the package for the model file. It should be just enough code to load the model. That's it. And the nice thing about this is it allows you to easily version the model separately from everything else, and that can be beneficial. And then of course the package for the API. This will include, again, code for transforming or munging the data before it's passed on to the model to maybe do a prediction or something like that. This is where the code will go to orchestrate all these steps. Maybe code to validate inputs to the model or outputs. So what do we get from this? What do we get from splitting these things up and deploying and versioning them separately? So to kind of drive this home, let's imagine a scenario. It's not to imagine a scenario in which maybe we might find ourselves like a really big model file, 3 gigs or even more. So imagine that you have a very small bug in your API code. Maybe it's something as small as you forgot a parentheses. And so if you have all of this packaged together, now all of a sudden, because of a single character, a single byte, is causing you to have to repackage and redistribute this massive model file, right? You're having to repackage it, re-upload it to your package index. You're having to have a whole nother copy of your model file stored on that package index. Your users are having to re-download this freaking model, all because of a little character. That's unacceptable. So that's why we want to split these apart. So this is an example, a quick diagram of what the directory structure might look like, where you have a single project directory, then 3 sub-projects that represent the 3 different distribution packages. All right, so some cons of this. It's more complex. We'll have to build and ship at least 2 packages because we may not ship the fit code, right? So maybe it's the case that we have more than one model. So what should we do? Well, now here's a scheme that you can follow in order to include a variable number of models, right? So it's the case that you'll want to include each model file in its own separate package. And you'll also want to have a separate package for the code to fit those models. But you will want to have only one API package, right? You'll only want to have one end interface. If you find yourself wanting to have more than one, you should probably split that off into a separate project. So an example of this, let's say, a really classic example of a classifier would be classifying emails spam, not spam, for instance. Maybe you have a pre-processing step where you use maybe a topic model to reduce the dimensionality of the text and then feed that into a classifier, okay? So the code for the model, the topic model, and the classifier should go in separate packages. So the reason why is very similar to a reason that we've already discussed. So let's say you maybe make some adjustments to the hyperparameters of the classifier and you want to refit it. You haven't made any changes at all to the topic model. You've only changed the classifier, right? And again, topic models tend to be the files tend to be kind of large. So again, this allows you, by separating them into separate packages, it allows you to distribute the classifier that you've just updated, but not have to redistribute the topic model. So again, not having to upload that, not having to store it, not having to have users re-download it. Okay? So of course it doesn't work in reverse because of course the classifier will fundamentally depend upon the topic model. So if you retrain the topic model, you'll have to redistribute both, but you still get benefit. Okay, so and it's also the case that the code to compose these two, that will go in the API package. All right. So cons is even more complex. So many packages. And also you're going to find yourself quickly having duplicate code and duplicate effort. But there are solutions to these problems. Dealing with the issue of duplicate code and duplicate effort, example, like let's say the pre-processing code. It's likely the case that we're going to want to reuse the same pre-processing code for both fitting the model, for feeding data into the model when we're fitting it, and then also when we're feeding the data into a model to make predictions. And so the solution to this is to take that code and split it off into its own package. So yes, more packages. And so yeah, in that example, we would take the code for the pre-processing and split off into its own package and make it a dependency of the package that represents the fitting code and then also the API code package. Definitely some things to be mindful of, avoiding bad dependency patterns with all of these packages. Make sure you don't have any circular dependencies. And so if you have one package that depends on another, don't have that depend on that first package. It's very bad. Okay. It's also the case that, thinking about when we're listing our packages as dependencies within our own packages, our packages that depend on our own packages, right? We should list lower boundaries on the version number because that makes sure that our users aren't using very old versions of some of our packages. But be careful about specifying an upper bound. That sort of can potentially cause problems. More specifically, let's say if you specify an exact version of some of your dependencies, especially packages that you control. That really sort of, if you pin it to a specific version, you find yourself in a situation where you're losing a lot of the benefit of separating them out into different projects. Because if you specify a specific version, you are pinning yourself to an exact instance of that code. Because you might as well just have shipped it with it anyways. Because you're going to have to reship the other package in order to update that version dependency, that dependency's version. So, as some of you may be wondering, we're finding ourselves in a situation where we have a ton of packages and it's growing. So how can we handle this in a sane way? Let's say that we're making use of a remote repository for the packages like PyPI or a private one. So first of all, for creating these, a recommendation would be to go ahead and create a template subproject directory in which you have the setup.py file with all of the common configurations already filled out and stuff like that, and then just copy it each time you need to create a new subproject. And then also when it comes to uploading, building and uploading these distribution packages, as you finish coding them, build them and upload them once they're ready. You don't have to wait until everything is done to go through and build and deploy each one, right? And it's the same case with updates. When you update a package, just build and deploy it right there. It's not as daunting of a task as it seems to begin with. And then for our users, how are they going to handle installing all of these darn packages? Well, one solution would be to just hand them a requirements text. Okay. The nice thing about this is that we can list all our dependencies, we can list version numbers, and we can also specify where they're getting this package from. So for instance, let's say for some crazy reason, we had different packages in this project. Some of them may be hosted on PyPI, the public instance, or maybe also some are hosted on a private instance. Maybe some are hosted on GitHub. You can specify all those different locations in this file. Another option would be just to simply, for packages within our project that depend upon other packages within our project, just list those dependencies in their setup.py file. This way, because ultimately, the real package that our users are going to be concerned about is the API package, right? And we only have one of those. And all of the packages that we need them to install, if you look at the dependency graph, they'll all be connected to the API package. And so once they type, pip install, our API package, pip will automatically pull that down. It'll look at dependencies, go find them, look at their dependencies, find them, and pull them down and install them. So it's actually really simple. The preferred option, particularly if this is not an end application, but just a distribution package, is to go with the setup.py file option, option 2. So there are a number of reasons. One, it allows us to leave to the end application maintainers to specify the versions of the packages that should be included, where they should come from, because we're not explicitly listing where they should come from. Maybe they're going to come from a local directory on the server, maybe they're going to come from PyPI. We don't care. Leave that to someone else. Okay, so handling data. So on the training data, again, unless we're going to be distributing the fitting code, which we may not, or even if we do, it doesn't really matter as much unless we care about distributing it and sharing it, as it does matter what we do with the model files and any configuration files that we want to include in the packages and version. Okay, so just a final note, it would be great if we as a community maybe looked at creating just general best practices on how to package these machine learning solutions. Not anything specific to scikit-learn, not anything specific to TensorFlow, just general best practices using general packaging tools. That's it. Any questions? Yes. That's a good one. I'll have to ask my cousin. You know, considering how much drugs they did, they probably did. I mean, I found that at least because, again, we're not dealing with like a massive, massive web service, with each component, running on a separate server, right? It ends up being not terribly different than if we had it all in one package as far as like the difficulty of debugging. But it's definitely the case that I find that whenever I take this approach, my code ends up looking a lot better because I don't have like crazy spaghetti code because, actually, well, not physically, it's on a hard drive. But separating all this stuff out into different directories, there's a hard mental, separation between these different things, and it really cleans things up a lot, I find. And it's definitely the case that there's definitely a lot of similarities maybe to like web programming or something like that in the way that you might package that up or structure it. And I think that's great. I think it's great to look at what other communities are doing and try to bring that back. That's why I think using just general purpose Python packaging or even using make files and tarballs. I don't care. Just read up on it, look into it. Maybe it'll help you out. Yeah. Yes. Yeah. So are you saying that we're using LDA as a dimensionality reduction set for the classifier? I mean, this is sort of off topic. Well, yeah, I'm saying that you would ship them separately. Now, I mean, again, like this is where I say, in that example, I don't believe that you could ship them separately, but if you retrained LDA, you would also want to retrain the classifier and ship them both. But if you only retrain the classifier, you could ship that, but you wouldn't have to reship LDA, right? Well, but again, so especially if we're talking about LDA specifically, because I mean, it's a probabilistic model, you don't necessarily have guarantee of that. And it's also the case, why would you retrain it unless you made, like maybe you made some changes to the way that you defined what a token is for the purposes of your model. That's going to fundamentally alter the value of the output, right? And so you do need to retrain classifier. So again, I can't really think of an example where you would retrain LDA and find value from retraining it and not need to retrain the classifier, right? A third-party LDA. I mean, we're trying to go down the rabbit hole. Okay. I mean, we can discuss this more afterwards. Can you speak up? Is the mic on?
So could you please talk a bit more about data versioning, especially if we get to the data size where, it's still sort of manageable, but, you won't, I don't know, upload 10 gigs of data to GitHub, for example?
Absolutely. So it's definitely the case that, so in most of these scenarios, you wouldn't ship, first of all, the training data, and then the model file. Definitely once the model file gets to be quite large, then you might want to look to other solutions. Maybe it's the case that you create for the model package, instead of actually shipping the model file itself, you would ship that with like just enough code to maybe reach out to some sort of service where you're hosting it or something like that. I mean, definitely it's the case that most of these schemes target smaller solutions that maybe using like scikit-learn or something like that. But yeah. Does that answer the question?
Not really. So.
Oh, okay.
So I understand like the packaging part of it. Just
Yeah.
So even if I'm, let's say, hosting the data on S3, like versioning these bigger files is sort of an issue. Not many people do it, as far as I can see. And I'm just wondering if there is some way of fingerprinting the data or making sure that I'm not just like versioning the name of the folder I put that particular file in, or like doing something more sophisticated to have a better sense of if I'm still dealing with the same data or like
Yeah.
what changed in the meantime, these sort of things.
I mean, again, like, I mean, there's so many scenarios that you come up that would poke holes in this. Because again, I try to make this very general purpose. So there are very specific niche cases. I mean, something like that. I mean, I don't know. Maybe you could make use of, if you're using like a S3, you can enable versioning on the bucket, and then make sure that you're for each release of the package, you would make sure that you're pointing to a specific version of that bucket, of the file in the bucket. That would be potentially an option for that specific use case. And then, I mean, obviously, if you're using some kind of database, like say, making use of something called Datomic that includes like the concept of time for all of your data. You make use of something like that. But yeah, absolutely.
Yeah, so I'm, concerned about the size of these model files.
Yeah.
I take it most people are distributing this stuff via their private repos. The size is probably not so big an issue then. I don't know, does PyPI have any restrictions on how big a distribution package you can upload? Or?
I haven't found one yet. I mean, definitely do be kind. Definitely, if that's just something I should definitely probably note, is that definitely if you're doing Python's public index, this is something that they're providing to you for free, and that's very nice of them. Be kind, be nice to them, and definitely, yeah. Once again, I think I mentioned in a previous question. Definitely, if your file's starting to get pretty large, maybe look at hosting it elsewhere, right?
Just common sense. If it looks too big, it probably is.
For sure. Be kind, show common sense.
Hi, could you talk a little bit about how to submit packages for Spark, like in Spark packages for PySpark?
So I have little experience with doing that, and it kind of depends upon what you're making use of. So let's make. I think one project that makes it a lot easier is like, let's say you're making use of like, I think it's like Apache BigTop, which kind of makes sense because then you have like the tent for all the the circus animals that make up the Hadoop ecosystem, right? All those elephants. Well, because projects like that allow you to make use of scripts that define, pip install this, and so therefore, if you make use of something like this, you can just package your solution up in that, put it up on maybe a remote repository, maybe a private one, and then specify the pip install in the script that you pass on to Apache BigTop for installation on your cluster. Yeah, absolutely.
I just had a generic question about the process of splitting up the code in multiple packages. So they are tightly dependent on each other in a way that the fitted data requires to be used by the other by the API and so on and so forth. So how does it make it more complicated to test them? Do you need to now set up an integration environment to make sure that they are all working together well? If there are multiple versions out there in PyPy, what are the versions that will work and which break? doesn't it all make it a bit more complicated to manage if you split it up into multiple packages?
I mean, it's definitely the case that managing all these things, especially if you know, definitely with splitting up a project, you can go pretty crazy with it, right? You could have every single function or class that you write in a separate package. You can go really nuts with it. And definitely, if you go to the extreme with it, it can be very, very difficult to manage. And yeah, definitely, depending on the way that you structure it, integration tests would be a great idea. But it's also the case that, you know, so for example, you know, as far as the end consumer is concerned, we have one top-level package, and that's the API package. And that's where maybe you could specify a lot of your tests that concern how everything works together, right? Because in order to make use of that API package, you need to have all the other packages installed in the environment. Does that answer the question? Okay. Yeah. Yeah. And I mean, definitely, like, let's say, you know, in the scenario where we had the pre-processing code separated out into its own, you would maybe put tests specifically for the pre-processing code in there. But as far as how it interacts with, let's say, the other code in the API package, you would put the tests for that in the API package tests directory, right? And yeah, just simply unit tests would suffice for that. Any other questions?
Are you familiar with cookie cutter? Is that something that could help us out here?
I've actually never heard of that. What about it? Can you give a high-level summary real quick?
Just establishes templates for like pip or conda, things like that. I
cool.
was thinking maybe you knew there's maybe one that's helpful for deploying machine learning models.
I've never heard of that, no. But yeah, I mean, yeah, I've just personally found making use of setup tools and specifying setup.py file to, for the most part, be good enough. Now, obviously, you know, things get more complex, and you might want to start looking at some of these other tools for sure. Okay. Anything else?